Good morning, everyone. How are you today? Please come in, find a seat. There's still some. They're scattered around, but there are still seats for everyone. Thank you all for coming this morning. Are you having a good TechEd so far? Yes? Yes? Liven up a little? I know it's still early. Hopefully we've had coffee or whatever else. Was the keynote this morning? Everybody enjoy the keynote? Have a good start? Okay. So my name is Peter Provost. I am a Senior Program Manager Lead with Visual Studio Ultimate. We work on the Ultimate and the Premium parts of Visual Studio, but my focus has been on ALM tooling, and in particular, tooling targeting agile development and the practices that go with agile development. How many of you work in a place where you would say you do agile? You do Scrum or Extreme Programming or Crystal or any of the others? Okay. I always find this is somewhat funny because, 5 years ago when, I guess it was 4 years ago when I was in Barcelona for TechEd, and I asked the question, we get maybe 15% of the hands up. Maybe 20 if we're lucky. And now, no matter where I go, in the US, in Europe, everywhere around the world, we see all the hands are going up now. More and more people are embracing the agile methods. But of course, the practices that we do when we do agile development, like unit testing, are not about agile. Unit testing is about good software engineering. It's about software development where we pay attention to the quality of the code from the moment we start writing it. So I'm going to spend the next 73.5 minutes talking to you about the changes that we made in Visual Studio 2012 in the unit testing experience, talk about why we made these changes, and talk about where we're going with them in the future, because this is just a step along a road. But there we clearly had to make some pretty serious changes to turn us off of the road that we were on before. So let me just go ahead and get us started. The unit testing experience in 2012 Visual Studio, we started at the very beginning. And we had all kinds of ideas and plans and dreams. But we knew we wanted to make sure that we created an experience that was focused on the developer, the person who writes code every day. This is where unit testing really happens, where it really matters. The developer who is writing the code. While they are writing the code, they are writing the tests. I don't care if you do TDD and you want to do them before or you want to do them after, but you should do them close together. That's when you are in the best position to make a statement about this method will do that, and it will not do this. So we focused on the developer, writing and running their unit tests while they write their code. And it turns out that if you're doing TDD, it works. If you're doing something I jokingly call DDT, do it the other way. As long as they're close enough together, it works out very well. And we end up with a system that is well designed, well tested, and hopefully high quality. And I'll be talking about that more throughout the week, in particular when I get to my talk on Friday, where I talk about untestable code and how to test it. So I mentioned that we've made a lot of changes. How many of you are using the release candidate of 2012? I assume everyone has downloaded it. No, come on, more. Go download it. When you're finished with my session, skip the next one, go download it. Actually, you can probably get a copy from lots of people here. Anyway, we had lots and lots of feedback for a long time about the unit testing in Visual Studio. I remember, 10 years ago, before I joined Microsoft, I was an MVP, and I was a very passionate, supporter of Visual Studio, and I was very young embracer of agile methods, and I was TDD all the way and all of that good stuff. And I remember seeing the initial announcements that Visual Studio 2003 or 2005, VSTS, was going to have unit testing. I said, yes, this is great. They're going to ship NUnit. This is going to be great. Yeah, they didn't do that. But it was okay, right? It was okay for 2005. But, all of the other frameworks continued to move on. They continued to evolve. They developed new features. They also ran a lot faster. And since I was a TDD Agile guy, that speed really mattered to me. Because I don't want to wait. If I'm waiting for the compiler, waiting for the tests, waiting for anything, I get frustrated, I get very angry, and I want to be typing as fast as I can. And so the speed was a problem. We really didn't have any support for C++. Does anybody do C++ development here? You know, this has been a very interesting question for me to ask this year, as we've been seeing more and more embrace of C++ coming back. Because I was a C++ guy before .NET. C++ and COM, the old way. And we really have not had any good unit testing story for C++ development. We would very uncomfortably come up here in front of you and say, use /CLI and test it with .NET managed code. No, that's not going to make me very happy. Also, there was the problems with the experience, the Visual Studio experience, the runner, the view, the way test lists worked. All of these things were problematic. They felt like they were for testers. And I love my testers, I really do. I'm very passionate about good testers. There are people who can break software. And some people are very good at it. I'm not very good at it. But people who can break software are amazing people. But when we're talking about an experience that is targeted and designed for the developer, that is going to be a different experience than one that is targeted for a tester. And so when we find developers doing Agile and doing TDD, the experience that we had in previous versions of Visual Studio did not feel a very good fit for them. So I'm going to show you very quickly the new experience, and then after I do a quick demo, I'll show you all of the parts with some slides and talk about how and why all of those things came into existence. So let me just make sure I have this machine thing working. Good? Okay. So here we have Visual Studio 2012 Ultimate Release Candidate, the exact same version you can download. I don't have anything special here. And I want to show you a few things just to help us get started. So when I say File New Project and we go down and we look in the testing section, we find a unit test project. We've had this for a while. That's good. I'm not going to use it. Instead, I'm going to just create a class library. TEE Demo 1. Now, why am I creating a class library? Because I'm not going to use MS Test. So I'm going to use a different unit testing framework. I'm going to use xunit.net. It's a small framework created by Jim Newkirk and Brad Wilson. Jim Newkirk is the original author of NUnit and has been at Microsoft for quite a while now. And he and Brad Wilson, who is on the ASP.NET team, created this new framework that what they envisioned unit testing could be in the future. And it plugs directly into the Visual Studio experience now. So let me go ahead and make it be an XUnit project. I'm going to take advantage of NuGet. You guys have used NuGet? It's a wonderful way to find things. So we'll go online. We'll search for XUnit. And the internet will behave. I assume you all saw some of the wonderful demos yesterday where people were wanting to demo things and not getting the experience they wanted. OK. So what did it do there? It downloaded the XUnit support libraries. It copied them into my solution directory. It created a reference, did all of that for me. Done. And if we look in the references here, we can see XUnit. So now that I have this, I'm free to create tests. Now in XUnit, a test is decorated with an attribute called fact. OK? And I will write my first test. Namespace. There we go. And we want our test to fail, just so I can prove. Now, as I open up this window on the side here, this is our new Unit Test Explorer window. We collapsed the number of windows that you had to interact with as a developer when writing and working with your unit tests down to one. This is going to give you a simple view of your tests, very quickly let you run them, and access all of the information. So I'm just going to click Run. Our test failed. We get our stack trace, our source, double-click to go to the code, everything that we expect. And I'm using a third-party testing framework. Now, in order for me to use this third-party testing framework, what you didn't see me do right before I came on stage is I went into the extension manager and I installed the XUnit runner for Visual Studio 2012. And I got this off of the Visual Studio gallery, one click, 15 seconds, download, and I have it. You'll notice I also have installed in here a framework support for NUnit. Is everybody familiar with NUnit, of course? And if you are working with JavaScript, perhaps in your HTML5 applications, there's a gentleman who's created this one called Chutzpah, which is capable of running jQuery, which is QUnit, and Jasmine, which is the BDD framework for JavaScript. It'll run those natively. And I'll show you some more of that later. OK, so we do that. Now let's make our test pass. It'll run again. Now, a couple of things about this window that I want to demonstrate. With only a single test, you're not seeing it, but as I do some more demonstrations and write and open some projects with a lot more tests, you'll see some more of these things happening. The green bar at the top, you notice this green bar. This is always your status indicator of the current run, the most recent run you did. So while that run is progressing, the bar is going across. It sounds like a very simple concept, but we did not have it for the last 10 years. And everybody who's a developer who writes tests wanted it because every other test runner has it. So there's our little green bar. We also have some nice searching here. So if I were to copy this test a few times, just so we have some quantity. OK, we'll cheat. Do a little cheat here. It's not going to work. OK, there we go. Now we have some more tests to look at. And you can see they're showing as not run. Here. I'll do a run all. We have them all now. You probably still didn't see it because they're just too fast, but the bar is going across. Now, we also have some search. So if I want to go here and search for 4, I get that. And we can also search within the namespace. We can search within the project types. And if you drop this little box down here, you can see we have a bunch of kinds of things. So we can go by fully qualified name, by the path of where the test lives, a lot of things. And there are more of these kinds of filter criteria coming as well. And there's also coming post-RC now a bunch of different ways to group and organize the tests. So we're going to have new groupings instead of just the one we have now for what the result state of that test was. OK, and you notice also, I mentioned it, but I'll just show you. If I make the test fail and we look at the stack trace that we get, right, we've simplified the stack trace, but all of the information is still present. So here's the stack trace line, and you can see it's very short. But if I mouse over it, I get the full stack trace information. And of course, if I click it, it takes me directly to the code. The point of this was to simplify and let you work very quickly. And I will tell you that from a performance perspective, our tests are amazingly fast. And if you come to one of the sessions I'm going to do later this week, if we have time, I'm going to show you while I'm having a little bit of a talk, I'm going to run 25 or 30,000 tests in about 3.5 minutes. We have some teams inside of Microsoft who are using this and are running over 36,000 tests when the developers do a build. And they run in about 6.5, 7 minutes. OK? All right, let me click back over to here. So what did we see there? So the red-green bar, again, I mentioned this. All of our run details are simplified down here at the bottom. Now, what I didn't show you, and we'll see it in some future tests, is when the tests have, when they produce output, console output and things like that, we'll get a link here that'll open it in a full document. We also have the tests from all of these different frameworks. Shaking. The test timings, also very, very useful. In fact, when I mentioned that we now have the support for the different groupings, one of the groupings we've added that is my favorite is the group by runtime. It helps me find the slow tests. The slow tests go right to the top. I can find them, easily fix them, make them fast again. Speed matters when you're doing your unit testing at the same time you're doing development. And we try to always float the most important tests to the top. Right? The ones you care about are the ones that are failing. The passing tests are really not very important. They're doing exactly what you would expect them to do. OK? And please, if you have questions, go ahead and raise your hand. I don't know. Do we have microphones? I guess not. So we'll just have to yell them, and I'll repeat them. So how does this work on the inside? This is another one of the important changes that we made. In order to allow the third-party frameworks to plug into us, we had to change the way the system works internally. Now, at the top of my diagram here, I have three kind of user interfaces for interacting with unit tests. We have, of course, the Visual Studio that sits at the top. That was the window I was showing you there. There is a command line runner, and we have the team build activity for TFS. All of these sit on top of the same engine, and this is kind of a test runner, right? It knows how to run test runners. It isn't a runner itself. We call it the Visual Studio Unit Test Platform. And then the test framework authors can create plugins that will plug into the bottom using a very simple API. So I helped all of the frameworks that we now have plugged in. I worked with each of those teams to help get them plugged in. And most of them, the source is available online, and so you can go and see exactly how they did it. And in some cases, for XUnit, for example, the entire plugin code is about 175 lines of code to do the plugin. So we made this very easy for the test framework adapters to plug in. And in fact, we're now starting to see more and more interest in plugging in new kinds of frameworks. And again, you don't have to be a managed code framework to plug in. You can plug in pretty much anything, because if you think about the adapter for JUnit and for Jasmine, what his adapter actually does is it shells out and runs an instance of a headless web browser called Phantom.js. He runs that headless web browser against the pages and then collects the results from the output stream and translates them into what we need inside of Visual Studio, and we get this wonderful integrated experience. But he's just shelling out to an external runner, and that works just fine. So we have all these wonderful plugins that are coming at the bottom. These all exist today on the Visual Studio Gallery. In fact, MBUnit is also now available. And I have been talking to some people who are interested in bringing on some of the new BDD frameworks like MSpec and some of the others. So this stack is what makes it all go. And what's nice about this then is regardless of which user interface frame you're using at the top, whether you want to work from the command line or from Team Build or from Visual Studio, you can use the exact same runners. Everything just works the same. And you can even use it if you're using Team Foundation Build in the cloud. So in the box, I mentioned earlier that we had been telling a not very nice story about how to do C++, and we had a bunch of hands go up for C++ development. We are now including in the box a native C++ unit testing framework. This is not .NET. It is pure C++. It has some attributes. There are some characteristics that were derived from some of the C++ unit testing frameworks that were developed inside of Microsoft on many of the teams around the company. And cleaned up and simplified and documented and put out, and also with a plugin for us. So now, out of the box, with Visual Studio, you can do .NET, and you can do C++. And of course, we have all of the other third-party frameworks that I've been mentioning, including up and coming soon will be SQL Server. So that will allow us to continue. And I'm working with them to try to get a very tightly integrated, natural SQL Server-based experience. So one of the critiques of MS Test, of course, was the fact that it didn't introduce any new features for really 7 or 8 years. I still think there are a bunch of features that I would like to see us put into MS Test. How many of you are using MS Test as your primary unit testing framework? Okay. Okay, now hands back down. How many are using NUnit? See, it's about the same number. And is anybody using XUnit.net? 4 of us. We should talk afterwards. So, of course, these other frameworks, they evolve very rapidly, right? They're open source, they have a lot of community involvement, and they're always pushing the edge on techniques that we can start to do to either make our tests faster or simpler or easier to understand. And MS Test, of course, did not really evolve very quickly. But there are a few things we've done for this release that I want to make sure to point out. The performance and scale is better than it has ever been. And it was already pretty good for Visual Studio 2010. We did a lot for 2010, although most people probably didn't notice it because they had already given up. But it is very, very fast. In fact, we have a dedicated runner now that when it is able to switch over to the speed runner, it runs like 50% faster than the older runner. There's actually 2 MS Test runners inside of Visual Studio now. And if you're doing what we would call classical unit testing, so you're just newing up classes and calling them, and you're not doing anything strange in terms of MS Test's extensibility points, like host adapters and things like that, it will always try to use the fast runner. The fast runner is named Duronto, which is the name of the bullet train in India. And so that's kind of telling you what the intent of it is. Very, very fast. Now, so it is very, very quick. The other thing we've added is async support. So if you have seen, if you've been playing around with any of the new APIs for Windows 8 development, and also you've probably been looking at some of the APIs in the base class library for .NET, you probably have noticed this async thing coming up a lot more, right? So this was a CTP, the task parallels library for a long time, and now it's baked right in and starting to become very, very common in the APIs. And I would recommend, in fact, that you take a really strong look at it as a way of encapsulating any existing asynchronous calls that you may have. It makes them very, very testable. It also makes them very easy to control and manage. And the async stuff, of course, works from both C++ and managed code. And you can see now we support the idea of async unit tests. We decorate the test itself with the async keyword, and we have it return a task. You'll notice it doesn't actually return, because anytime you decorate an async method with task, the compiler actually generates that for you and produces a state machine under the covers that hides all of that and just makes it happen. But this method is now capable of being async. And because it has the async keyword, we then can use await. And await is really the magic word that makes a lot of things possible, because this some long-running operation also returns a task, and then we can await on it and set all of that up. So let me show you why this is important. A lot of people say to me, why does this matter? Why is it important that the test frameworks support async? And I'll show you that in just one second. In the last few versions of MS Test, we didn't really have very good 64-bit support, and it didn't do .NET multi-targeting very well. All of that stuff has now been cleaned up. And then the final thing that a lot of people are very excited about is that we now have MS Test and this unit testing experience in our Express level SKUs. So if you're using Express for Windows 8, the newly announced Express for Windows Desktop, or Express for the web, the unit testing experience is going to be right there for you. Everybody gets to do unit testing now, the way it should be. But let's take a look at this async unit testing experience, so I can explain why this matters. Because it is an interesting problem that you may not have run into before. I'm going to just continue to use the project that we have. And what I'm going to do is I'm just going to simulate up an example problem for us. I'll create a class, and we'll just call it business object. It's a good name. And so this is the class we want to test. And let's imagine that this test has that operation that we saw in the code just a minute ago. So what is it really going to look like? Well, it is going to be an async. It's going to return a task. And this is going to be some long-running operation. Okay? Now, what is this really telling us? It's telling the compiler to be prepared to generate the necessary state machines under the covers to make all of this work. Now, where this really comes to bear is when we have in a situation of a side effect. This is when it will be most obvious to you as a unit tester. So we're going to have this property I'll call will be updated. And what's really going to happen is anytime you call this method, it is going to spin up a task, which is a background process. It's going to cause it to run. It's going to get scheduled for execution. I'm going to have that thread sleep for just a second, just to prove that there is a delay. And then I'm going to update the other property. We do this very simply, so I'll just say return task.run. Actually, task of string. There we go. Run. And I'm going to use a lambda expression. I've been finding people sometimes struggle a bit with lambda expressions, but of course, they're just a delegate. It's just an anonymous delegate that I didn't have to declare very much. So we now are going to declare this thing. It is going to, as I mentioned, we'll do a thread.sleep. Oops. And I'll sleep for 2,000 milliseconds, just to prove. And then we will update our string. Okay? Now, something wrong? Ah, yes. task of string. Now let's just do this. He doesn't need to return the string. Okay. Okay. So a couple of interesting things about this. First of all, you'll notice I'm getting some squiggly lines. We should try to figure out why. The first one is basically telling me this method has the async keyword but doesn't use await. And this is one of the things that caught me when I first started learning async programming, is that really the async keyword does not say that you're going to be creating tasks and creating background operations. It says you need to consume them. And in fact, this method does not consume them, so I don't need that at all. By returning a task, I am an awaitable operation. And then we return this. We should be good now. There we go. So now we're returning the task. The task is being set to run. It's going to sleep for 2,000 seconds, and then it's going to update that. Now, how do we write a unit test for this? So if we go back over to our existing test project and just put a new test here. Actually, we're going to do this with MS Test. So I'll go ahead and create a unit test project. We'll add a reference from the unit test project over to the other project. And now we're going to need to make this an async test. Actually, let's not make it an async test. So we're going to create an instance of our business object. Okay? And then we will say some long-running operation. Now, if we were to just do this, and then we'll assert equal on the property. So SUT dot will be updated. So this is the kind of a test that we would normally like to write. We would like to write a test that simply calls the method, checks the property. Now this test, interestingly, is going to fail. There it is. We'll run it, and it failed. And it failed, of course, because this line, assert r equals, happened long before that 2-second wait happened. In fact, you'll notice this test finished in 9 milliseconds. So sometime long after this test finished is when that operation finally executed. So clearly we have to have a way of saying stop, wait until it's finished. And that's exactly what the await keyword is for. But of course we cannot use the await keyword unless we are async. And async void is evil. So we will say async task. Sorry, the async void is evil is a bit of a joke. It turns out it is quite challenging using reflection to detect an async method that does not return a task. There are ways to do it, but this is a much cleaner approach. It makes it much clearer to the consumer that we say this is going to return a task. And the unit test framework of MS Test actually requires you to do async task and not async void. If you do async void, he will not run it correctly. He won't run it with the various pooling, and he won't block and wait for it. Okay? So now we should be able to build and run this test. And test method now passes. So we're able to do the blocking and the waiting without any problems. Now, xunit.net also supports the async task on its unit tests with no special decorations other than the signature change. And I've heard that NUnit will be supporting it soon. So if you are an NUnit user, and a whole bunch of you did raise your hand for NUnit, and you want that support, you should put a note up on their forums and make sure to let Charlie Poole know that you want to see asynchronous support. Okay. So now we have shown the async. We can kick back over to here. So this is new with MS Test. In addition to the performance, you saw those tests were running in 9 milliseconds and extremely fast. Okay. One of the questions that we get asked quite a bit about all of these changes is about compatibility. Because, of course, as you are considering adopting a new version of Visual Studio, many organizations will find themselves in a position where they are going to be mixed mode for a while. You'll have some members of the team using the 2012 and some members of the team still using 2010 and maybe even 2008. I met with a customer who said that she had on the same computer, she had installed 2008, 2010, and 2012 beta all side by side, because she needed to use them all at the same time. I use virtual machines for that, and Brian Randall has a talk on virtual machine development later, and I would recommend you go see it. But we know this is real. We know this happens. And of course, Visual Studio 2012 has a very strong story for round trip and backwards compatibility with 2010, and we kept that in the unit testing world. Our intent is it will just work. You should not even have to change anything. Everything should just work. Now, there are some things that are a little bit different, and I'll point out some more of them as we continue through some more of the demonstrations. Things where you can actually have some optimizations in your process and optimizations in the test runtime and things like that, if you can commit to all 2012. But if you can't, that's OK. And if you find yourself where you need to run using the old test runner, there are a couple of tricks you can do that are described in the documentation to make Visual Studio do it. And in TFS, for team build, there's actually a drop-down option where you can choose to use the Visual Studio 2010 runner. And it is the same one from the old project. So if you have a system where you find one of these cases where our intent of just work did not quite succeed, you can still drop back and continue to use the old runner. Because they're very quiet, no questions, no hands. OK. Of course, when we're writing unit testing, and we're doing testing of small units, and I'm very explicit when I define unit testing as the smallest bit of code that I can test in isolation from other bits of code. When we want to do that kind of testing, we have to have a way of achieving the isolation. And of course, we've probably all heard of mock frameworks. We know of MOQ and NMOC and things like that. But also, of course, doing isolation requires you to have some design, make some very strong decisions about how you do your design. And I'll be talking about some of those design principles on Friday. But still, you're going to have situations, they're unavoidable, where you have code that you need to figure out how to isolate. In 2012 Visual Studio, we've introduced a thing we call the fakes framework. The fakes framework has two parts: stubs, which are very similar to, but not the same as, the mocks that you get from other frameworks like MOQ and NMOC and Rhino. But it's similar. And we also have shims. And shims are a little bit different. Shims allow you to do runtime interception and detouring. You actually can inject at runtime in front of any call in .NET and prevent it from happening and return any value that you want. So this allows you now to test your code in complete isolation of the external world. And so with both of these, we are now able to make tests that are very strongly isolated from the surrounding environment so that we know our test is targeting exactly what we want it to target and nothing else. This is important when we are doing that very small loop of test and code and test and code and test and code, because we do not have time for tests that spin up the entire world and take minutes and minutes to run. So I mentioned the customer who, the internal team that has 36,000 unit tests that run in 6 minutes or something. I met a customer at TechEd in US 2 weeks ago who has 47 tests total, and they take 29 minutes to run. And he called them unit tests. I don't think they're unit tests. Or it's a big unit. So let's take a look at fakes. OK. I have to look out for hands every now and then. Click over to here. OK. So I'm going to, using the same project system that we already have here, I'm going to just do a little bit of cleanup. Let's get rid of that. So we still have our business object here. OK. Now let's suppose that in our business object, the method that we're going to create now is a method that is going to help us deal with the Y2K problem. We all remember that, at least some of us who are old enough. Remember the Y2K problem? Right? So perhaps this method says, check if end of world. Because that's what everybody thought was going to happen, right? if it's the end of the world, if it's 2000, I'm going to say if datetime.now is, let's see, datetime.from, let's do it the other way. So it was 2000, January 1st. So if it's that, throw new Y2K exception. Okay. And perhaps this is the entirety of our test, our entirety of the system. I have to create my exception really quick. No problem. Good, good, good. Okay. So now, how are we going to test this? The problem with testing this is it has a very strong environmental dependency right now. Testing this in a way that isolates you from the current time of your machine is very difficult. How might we go about this? Well, one of my favorite ways, and I'm not going to type in the code for you, but you can imagine if I was to do it, is I change the system clock. And then hope from that time until the time I run my code, very few things happen. And then I check maybe with a window of, a second, and, you do your best. It's never going to be a very dependable test. And of course, now you have to remember to change the system clock back, and if things crash and fail, suddenly your build server thinks it's 2000. We don't want that. So instead, we're going to take advantage of shims. Now, what we want to do now is we want to make that datetime.now go away. Okay. So here's what we do. In our test project, datetime lives in the system assembly. So I'm going to go to the system assembly. I'm going to right-click, and I'm going to add a fakes assembly. Okay? Simple one-click operation. What it is doing right now is it's scanning the system and MS Core Lib and generating 2 new assemblies, and it's going to put the references in for me. These new assemblies are going to contain stubs for all of the interfaces that it finds and shims for all of the classes. Now, it turns out that because this is the system reference, it isn't all of the classes. If you understand even a little bit about how unit test frameworks work, you can understand why perhaps it's very dangerous for me to let you shim out app domain. Right? Because, of course, all of the test frameworks will use app domains to create isolation of the tests from the runner so that the crashing test doesn't crash the runner. But if you could take over app domain, yeah, we would have a bit of a problem. So we, in fact, use what we call a whitelist, and only certain assemblies in system will get shimmed by default. You can override that. And if you come to my fakes talk on Friday, I'll take you through all of the crazy how to make fakes do wacky things like that. But for now, what we're going to do is take advantage of this. So we got 2 fakes references, MS Core Lib and system. And we'll now write a test that tests our new method. Okay? Date time, or end of world checker. Okay. It's still yellow. Okay. Good. So we need to spin up our business object again. And we're going to call check if end of world. Let's see. So this is a method that throws, so we're probably going to have to use our expected exception. Type of Y2K exception. Okay. Now, if I run this test right now, of course, this test is not going to pass. And it's not going to pass, of course, because it's, what is it, 6/27/2012. So here's our problem. So what we want to do is we're going to take advantage of the shim that was created for us. Now, the naming convention we have here is the word shim, followed by the type that you want to manipulate. So what I want to do is I want to take over date time. So I'm going to type shim date time. Now, Visual Studio is going to offer me the namespace system.fakes. These types are always put in a namespace of .fakes from where the parent comes from. Very consistent convention here. So now that I've done that, I can push dot, and we'll see we have now get. Well, why is it now get? Well, it's a static property called now. Properties have getter and setter methods. This is how we're differentiating them. So it's the now static property getter method. And it turns out I just make an assignment to this. I assign a delegate. I'm going to use a lambda expression again, but I could use any delegate. It could even be a method on this class. And I'm just now going to return a new date time like that. OK? There we go. So now what happens if I run my tests? Let's see. It failed again. And what did it tell me? I have to open this window a little bit because this message is long, but intentionally long. You'll see what it is telling us here is I used a shim without providing a scope. So let me explain to you the problem here. When I do what a shim override like I did, where I said now get equals some lambda, some delegate, that is forever in this app domain. And clearly, that's too long. Imagine, again, app domain. Okay? We don't want it to be forever. We want it to be very tightly constrained. And so if we ever find you using a shim without providing a scope, we will throw. There really isn't a technical reason for us to have done this, but trust me, it's the right thing to have done. So we force you to wrap this up in a scope to make a conscious decision to scope the area in which this substitution is valid. And when that scope expires, the substitution is removed. Now, we do that, and you can see the sample code is actually given in the exception message. To make it very easy, you don't even have to go digging in the docs to find it. And so I'm just going to type in that exact same block of code. Now, for people who are perhaps worried that this is, an expensive operation, and maybe you want to try to do it at the top of your method, in your test setup or something, it is not an expensive operation. It is a very, very small, fast operation, this shims context.create. So don't worry about it. Use it like this. I really strongly recommend you use it like this. And one of the reasons is because you don't know what your test runner does between two test methods. And what if it wants to call a method that you have overridden? So you've chosen to override datetime.now, all is well. Maybe NUnit calls datetime.now when a single test finishes. And now he gets your value because you set up your scope in the test setup. So I really strongly recommend you don't do that. Hopefully that makes sense. Let's run again. All right. So we took over datetime.now. We proved that we can take over a type, whether it's in the base class library or in your existing system. Yes, a question here. All right, so the question was, is this what used to be called Microsoft moles? Have you guys heard of PEX and moles and stubs? So it is derived from moles and stubs from the PEX project. We worked very closely with Microsoft Research, and we extracted this technology from them. It is not exactly the same. It doesn't use the same profiler, for example. It's a completely different profiler. We're using a profiler that we already have inside of Visual Studio that's designed for performance and scalability and all those other things. And that profiler is shared across a number of different features within Visual Studio. We integrated it better into the Visual Studio experience. We changed some of the naming conventions based on user feedback and things like that. So the technology is derived from moles. It's not backwards compatible with moles. Moles. So if you're using moles today, it will not just be a free upgrade to the new technology. But I have been talking to Peli and Nikolai from the MSR team, trying to encourage them to create a converter, and they're considering it. So if you're using moles today, perhaps a couple of emails, a little pressure on them. They're going to be mad at me for telling you to do that, but that's OK. It's good. We've got to put pressure on people sometimes. So this let us use the shims. Now, sometimes you're going to want to use stubs. Okay, and stubs are very, very lightweight. They don't have any profiler requirements. They run very, very fast. They're extremely small. It is basically a class that implements an interface. And so if we just take a look at what we've already picked up, you can see we've picked up stub_appdomain. Well, what is that one? Well, that's because there's an interface in MS_corelib named _appdomain. This is not the appdomain we were worried about a minute ago. This is just an interface. But if we had a business object that consumed an _appdomain, we could create one of these instead. Okay. And we use it in exactly the same way we use the shims. We have the properties, and we assign to them delegates that make the implementations work. Now, this is an interesting case where we are different from moles, to kind of bring that back here again. In moles, everything had to be explicitly declared. Even methods you maybe didn't care about. You just wanted the default value, or you wanted it to do a no-op. Clearly, when we know that when we're using these in a rapid development cycle, a TDD cycle, sometimes you just want the default values. So we inverted that. And now the default is the default. So in other words, if it's a method that returns an object, it'll return null. If it returns a value, it'll return default of that value. But we do it exactly the same way. So we can just look and see, here we go, assembly load event. We can look what it is. It's an event handler, so we can assign it then to some sort of an event handler structure, and we can go on from there. Now, stubs do not have the scoping requirement of this shims context create, because we're not taking over somebody else's code. It's just an object that implements an interface that you can use to pass around. Again, I'll be covering this a lot more in my talk on Friday. Any other questions about fakes before I move on? Yes, question over here. Right, so the question was, does it work only on public interfaces? Well, it does not work on private. If you use the internals visible to, you should get access. Okay? A lot of people like to use the internals visible to as a way of making something public to the testing project. So yes, you can get access like that. It is meant to be used in the same kind of a way that MOQ and NMOC and Rhino are, that it will provide the implementation that you can use. For example, if you were doing a dependency injection, whether manual dependency injection or via an inject or Unity or one of the other frameworks, you're often creating these interfaces and passing them in via the constructor. You want to be able to do that in your test. That's the target, and so that's what it's for. One of the other things that people often recognize at this point is that I generated this, right? Remember when I added that reference, I generated these assemblies. And people get concerned about the time and the cost of that generation. They will only be regenerated if the target changes. And of course, MS Core Lib won't. So that one will not get regenerated again. Now, if I'm creating a fake assembly against my project, it will change when your project changes. And if you come again to the talk on Friday, I'll show you a lot of ways to tune that and to shrink down how much gets generated and to make it faster, to really constrain that to the smallest possible set if that's a problem for you. All right, any other questions before I move on? Oh, one more right here. I'm sorry, can you maybe stand? It will help me hear you. Okay, so the question is, do we have behavioral verification like in MOQ? So if you're familiar with that concept, the idea is you set up your mock object, you execute a call, and then you verify that the mock object received the right kinds of callbacks. So we do not have that built right into stubs in the product right now. In my talk on Friday, I will show you at least 2 different techniques for doing it, and I will tell you that it is something we're looking at including. It may come a little bit after, but it is something we're interested in including. We're having a lot of customer feedback expressing a lot of interest in that capability. How many of you want me to put behavioral verification in stubs? Okay. That's about what I expected, about a quarter of the room. Okay, excellent. I'm going to move on, and of course I will still be around and we can talk more after. Okay, so the fakes framework now built into the product. I want to be completely crystal clear and transparent. It is in the ultimate product. So I do have a few recommendations for people when they're using this framework, this capability. Stubs are a very natural approach if you're doing TDD, if you're doing a lot of unit testing, if you're using interface injection, if you're using dependency injection frameworks, if you're already using MOQ or NMOC or Rhino or any of those things, it's going to feel very natural. The language is a little bit different. One of the things we decided to do was to stick entirely to the language constructs provided by C# and VB and the languages we have, and not create a new API for you to learn. So that's why we have the properties and the delegates and simple assignment. Instead of, if you look at how MOQ does it with .setup, .returns, all this language you have to learn, we decided not to go there. Keep it simple. And stubs are very powerful, very fast. I would recommend you use them. They're good. Shims, on the other hand, you'll see I say they're amazingly powerful, but they're evil. And we say they're evil because they really do let you do things that are pretty bad. And they will let you create some terribly designed code, terrible designs, and still test it. That's cool if you have terribly designed code, but I would really strongly recommend not to fall into the trap of letting this give you an excuse to create terribly designed code. Okay, let's always focus on writing really good quality code, very modular, decoupled code. And so the recommendation I give to people is, if you have to use shims in your tests, that's fine, use them. But stop and think about, can I fix this? Can I clean this up? Can I make that requirement to use shims go away? Can I replace it with an interface? Refactor that code and make it clean. And here's that session I mentioned earlier that I'll be doing on Friday. Excuse me 1 second, I must cough. Oh, I turned off and it didn't work. Sorry. The switch says off. Okay. Switching gears. Of course, code coverage is a very natural thing for us to want to talk about when we're talking about unit testing. And I love getting up on stage and demonstrating how to turn on code coverage in the Visual Studio 2010 version, or 8 or 5. We've all done this if you know about code coverage, right? You double-click on your test settings file, and then you scroll down and you find the data collectors section, and then you go into the data collectors section and you check the box next to code coverage, and then you say OK, and you run your test and you don't get any code coverage data. So you do it again, and then you realize there's a thing that doesn't look like a button, but it is, and you click that, and then a new thing comes up and you have to check the assemblies that you want, but you can't say all, so later when you add a new assembly you have to go back and do it again. And then after you do all of that, you run your tests, and you get your code coverage data back. And then when you want to turn it off, you have to undo all of that again. And remember, when we're developers writing unit tests while they write their code, really asking about the code coverage is a question we're asking our system. Tell me, how am I doing? Am I doing pretty good? Am I not doing very good? And so you'd like to be able to ask that question very easily. You want to be able to ask it with just a single click. So we acknowledge that this is one of the things people needed to be able to do. And let me show you what we did. So I switched over to a project. This project is very soon going to be posted up onto a Codeplex site that I've created called Visual Studio 2012 Unit Testing Samples. All of the code that you'll see me demoing this week will be up on that site eventually. And it's just it has a client application that talks to a web service and blah, blah, blah. And I have a bunch of unit tests that test the various components, and I want to see, how am I doing? Well, instead of the test settings file and all of those other things, I just say, tell me how I'm doing. Run, analyze code coverage. Does a quick build, turns on the code coverage engine behind the scenes, instruments all of the assemblies, and then gives me back the answer. There goes the run. And by the way, I am using xunit.net. So here we are now having code coverage reporting with third-party unit testing frameworks. And here's my code coverage reporting down here. We can take a look at the results. And you can see on some of these assemblies, I'm doing OK. In fact, on my view model stuff, I'm at 99%. Not bad. And some of the other things, I'm not doing very well at all. And of course, all of the things that you're used to in our code coverage stuff is present. So I can go here and turn on the coloring, and we can scan and look for red. Red is bad. So clearly, I don't have a test that successfully calls that line of code. But I did pretty good on the rest. Not too bad. Oh, there's a bad one. OK. Simple, easy to turn on. Now, because, again, the developer, he wants to write his tests and run his code, sometimes what you're doing is you say, that test I just wrote, or the last 3 or 4 tests that I just wrote, tell me about their code coverage. Well, it's actually quite simple to do now. You just select the ones you want, right-click, analyze their code coverage. So now we're going to initiate a test run that only includes those tests, just those. You can see the rest of them are all now grayed out. And I'm going to get code coverage results back. And so now when I turn on the coloring, there's a lot more red because I ran a much smaller set of tests, but I can now see exactly what those tests are touching and what they're not. If you are writing tests after the fact, this is really valuable because you can find where your test didn't go where you expected it to go and where you wanted it to go. Okay? So that's code coverage. The other thing that I wanted to show you real quick is, of course, I'm using xunit.net here. And perhaps what I want to do is I want to debug a test. Well, xunit is a managed .NET framework, testing framework, so I should be able to put breakpoints here, just like this. And I should be able to select the same set of tests, or a single test, and debug them. And here we are now, stepping into our tests. Also notice our IntelliTrace data. I'm in the Ultimate SKU, so I have IntelliTrace. So I'm also collecting IntelliTrace data while doing this test run. So all of this stuff is now tightly integrated, and you can use NUnit or XUnit or whatever framework you want to use. Yes, question in the front again. No, code coverage is not available in every Visual Studio SKU. Code coverage, I want to say it's the premium SKU. I would need to check the matrix. If you come to me after, I can have a quick peek. It's actually on the MSDN website, all of the features and exactly which SKUs they align to. I'd need to check. OK. So again, now I can continue to step in on my tests. I will warn you, when you're doing async, always remember to set a breakpoint inside the Lambda, or you won't get there. OK. We'll go ahead and stop. We don't need to continue that run. Let's go back over here. OK, so we can analyze the code coverage across our entire solution with a single click. And we can run selected tests to get code coverage on those. Supports all of the managed and native frameworks. So this works in the native code as well. Actually, I think there's a problem in RC, but trust me, it works for RTM. So if you're using C++ development, you're going to get all of the same capabilities. Easy to use. Keep it fast. OK. So I mentioned before Team Build, and you remember in the architectural diagram where I showed the layers at the top, Team Build was one of the frameworks up there. Now, I've been talking a lot about third-party testing frameworks, and so you can imagine we might have an interesting challenge if we want to start talking about having our Team Build using third-party testing frameworks. All of the things that I've been showing you, so that includes fakes, third-party frameworks, code coverage, all of these are going to work in Team Build as well. Again, our goal here is that if it works in Visual Studio, it works in Team Build. You shouldn't have a different experience there. We depend on our build servers for continuous integration, for that constant communication with the code that we've checked into the repository to know that it's good, that it's safe, that it's happy. Okay? Team Build also can do test impact analysis, which can be very useful for your QA teams to understand perhaps what areas they need to go and target with either manual or exploratory or targeted automated testing. And it works in the hosted cloud build. And provided the internet continues to work for me, I'm going to show you that. I heard yesterday was a not very good day for the internet, so let's cross our fingers and hope good things. OK. So I have this project that I was showing you before. This is the one that does the earthquake thing. I'll just run it really quick to show you. I have to kill all of these breakpoints. Just so you can understand what the app does. All right, so it reaches out to a web service and gets back all of the earthquake information for the last 24 hours or something. And I plot them up on a map, and it's a nice map control, so we can look around and figure out where all of the earthquakes are happening. And we can see Alaska has been pretty busy today. So that's the app. Now, what I want to be able to do is get all of this to work and run up on the build server. Now, there's a couple of interesting things inside of this project. First of all, if we look here, I have a JavaScript test. This is using the QUnit testing framework in JavaScript. I have that because this project also contains a web service that you're not seeing. It's behind the scenes. But I wanted to put this in just so you could see two things. First of all, I'm using JavaScript unit testing, and secondly, it's going to work on the server. Now this project has been checked into my own TFS instance in the cloud. So if we go and we take a look, we can see it's connected to my own system up here. My name, tfspreview.com. No, you can't get there. But let's go take a look at builds. So as part of my account on TFS Preview, I have a hosted build environment. And so this lets me create my own build definitions that will run up there. Now, one of the problems we have, of course, is when we built that hosted build instance for you guys to use, we don't know if you're going to use XUnit, or Chutzpah, or NUnit, or any of these others. We don't know. So we can't install all of the adapters. We don't even want to get into the business of having to install their adapters because we want them to ship versions. We want you to have the kind of control over that. So instead, what we have to do is we have to think of a way to get the adapter up to the build server. What we have right now is not yet perfect, but it works, and I'll show you how we do it. And I'm working with Chris Patterson, who's giving some talks here this week as well, to try to come up with a better system for us moving forward. Basically, what I did is I took the v6 file that you get from the Visual Studio Gallery. So that is the xunit.net downloads as a v6 file. And you can go to the website and download it yourself. Turns out a v6 file is really just a zip file, so you can rename it and open it. I did that, and then I took the files and I checked them into my system. And if we take a look inside, we have inside the project here, I have unit test plugins. I just took all the files and plopped them in this directory and checked it in. So now the runner is now part of my check-in. Then I go to the build controller. And in the build controller's configuration, I just reference that folder in this one line right here. That's all I had to do. And now I can do check-ins, and all of the test frameworks will be executed using that same stack I showed you before, with the unit test runner framework in the middle and the plugins sitting at the bottom. And so we can go and take a look at my builds. And let's see, what has happened in the last 14 days? Oh, 2 failed builds. And these are failed because when I was at TechEd, I was intentionally failing the tests. So I'm not sure how long this one will take to run, but we can queue one up. While that one's queued up, we'll go ahead and take a look at one of these older ones and see what happened. And we can see that it ran my tests, because here it says 2 test runs completed, because there's multiple test projects with multiple test runners. And it's giving us now the information of what happened. Somebody returned the wrong JSON data. A date expectation was incorrectly matched. And then I can go ahead and click on the details for the run. It'll download those test results just like you were accustomed to in Team Build before. We can look at the test results details and see exactly what happened and get back into our code. So all of this now happening up on the hosted build in the cloud. So whether you're using on-premises build or hosted build, this experience of using any test framework that you want with the code coverage, with all of the other features, should work for you. Okay. Questions on that? Yes, sir. The question is, do you still need to install Visual Studio on your build server to get code coverage? Yes. In fact, you need to install Visual Studio on your team build server to get lots of things. Chris and I have been talking about that quite a bit. And Chris Patterson from the TFS team is here. And if you want to give him some feedback about that, I would encourage you to either find him after one of his talks or before and let him know. He agrees with us, by the way, that this is not a good thing and that we should work to cleaning that up. We should not have to install the IDE into our environment. If you're an old guy like me, then you remember the days when running the app on a machine that had Visual Studio, it would work. But if you ran it on a machine that didn't have Visual Studio, it didn't. I see some heads nodding. But that's actually far less common than it used to be. Yeah, and there are a whole bunch of features that you get by installing Visual Studio into your build server. The code coverage is just one. There's actually a number of other things that you get as well. So I would suggest you talk to Chris if this is something that does concern you, and let him know your feelings and why you think this is important to you. Those are always the things that are the best for getting that kind of attention. So our build is still running, and we're not going to wait for it anymore, but it's trying. You can see it's crunching along here. The hosted build is of course, a shared instance being used by a number of different people. And let's continue. Back over to here. So Chris, who I've already mentioned a few times, has a favorite saying. And he basically says, if you're not running your unit tests, you're just compiling, you're not building. And this has come up a few times when we've had people talk about wanting to build, and they mean compile because they don't care about unit tests. And you might be surprised or not to find out that we have some people inside of Microsoft who feel that way. So, we're working to educate everyone and get everybody lined up here, but you clearly want to be running your unit tests when you build. And in fact, you probably want to be doing that in the IDE as well, not just on the build server. You want it. You really would like to have the unit test execution feel like a part of the build. Why should I have to do even the extra click? Okay. So let me get rid of these extra windows here. And I'll show you what we have created thus far. We still have more work to do here, but this is a good start. I'm going to clean the solution just so we're back to empty. And of course, the QUnit test doesn't go away because it's JavaScript and it's always there if the file is present. So anyway, I cleaned up, all the binaries are gone, the window's now empty. I'm going to turn on this option right here, run tests after build. It also exists up here, run tests after build. Now that I have this on, I don't have to think about the problem anymore. Now it's just anytime I build, I'm hands off the keyboard, so you see I'm not cheating. And you can see the build was pretty fast. And there goes the test run. And we have a failing test. It's the same one that was failing on the build server. So what this now lets me do is it lets me stop thinking about having to run the tests and instead just interact with the code. Of course, a lot of people now say to me at this point, but I don't, it's going to slow my Visual Studio down. It's going to mess things up. It's going to, make my code slow. And I'm going to show you that that is not the case. So I'm going to trigger a build with the key binding, Control-Shift-B. Okay? And then while that's happening, I'm going to start working in the editor. And I want you to observe if I have any lag issues. Okay? Here we go. Build. Okay? And so I'm in the editor. I'm opening new lines. I'm typing code. The run's already finished. You probably didn't even notice because you were watching me type. So I'll build again. All right? And I'll keep typing, keep changing lines, keep changing lines. There, it's done already. All of this is happening in a background process. In fact, the builds are now happening totally background, offline. So now nothing impacts your Visual Studio experience. I have sat doing demos with small groups of customers where I can TDD for 15 minutes, never pushing the run tests button, and constantly watching that window go red, green, red, green, red, green, red, green. Now, I often get somebody at this point who says, well, I like to use nCrunch or Mighty Moose. I like those products. I know those guys. And they say, well, it should do it on save. Well, there's actually a nice trick for that. You go up here, and you choose Customize, and you bind Control-S to build. Believe it or not, it works about the same. Because if you think about it, both nCrunch and Mighty Moose are using an out of Visual Studio process to do the build, and out of Visual Studio process to do the runs. They're running selected sets of tests. They're optimizing for performance and throughput and not interacting with your IDE. We have done all of that in Visual Studio. I will tell you it is not the same. Right? They are doing a much more aggressive job of reducing the number of tests that it runs. What we will do is we will run all of the failing tests, and if they pass, then we will run all tests. So we try to always stay caught up. Looking forward, we're going to be introducing a lot more interesting heuristics to try to bring that set down and start to control that set more. But for now, what we have is actually working quite well, even for teams working with 30,000 tests or more. So it's a good start. And it works quite nicely. And I'll tell you, my development team, when we first implemented the feature, they all switched over to it. And there's a couple of interesting things that you start to do when you start to develop in that way. You turn off the output window and you turn off a bunch of other things because you stop caring about them anymore and you just start building and watching your red, green bar, red, green bar, red, green bar. Okay. So built into Visual Studio now, Run your tests every time you do a build. And I really was only partly kidding about binding Control S to build. Or you just don't save anymore. Just build all the time. That's what I do. Because, of course, build forces the save as well. And the build process in Visual Studio is much, much faster than it used to be as well. You know, it used to be that even if you didn't change anything, it would stop on every project and kind of think, maybe I need to build that, maybe I don't. Now it just goes, done. Nothing to do here. And in fact, if there really is nothing to do here, we don't run the tests. We already ran them, and we didn't change anything, so why bother? Fast, fast, fast. OK. How many of you do SharePoint development? OK, just a few. You know, in the US, half the hands go up. So if you're doing SharePoint development, I want to give you a heads up that sometime in the post-RTM timeframe, we're going to be releasing some feature packs. You may have seen it if you read Jason Zander's blog. In that first feature pack, we're going to be including a lot of new stuff for SharePoint development. One of them is the thing we're calling the Test Emulation Library for SharePoint Unit Testing, which is basically a library built on top of fakes to make unit testing SharePoint much, much easier and much, much faster. So I don't have anything to demo for you for that today, but you should watch the various blogs, Jason and Brian, Harry, and others, and mine if you would like, and we'll have more information about that soon. And I already mentioned this earlier, but I want to point it out again, that in the Visual Studio Express SKUs for desktop, Windows 8, and web, we have now the unit testing experience. And so you get the same experience. Now, one of the challenges, of course, is that the Express SKUs do not allow third-party extensibility of any kind. So that means you cannot use XUnit or MBUnit or NUnit in the Express SKUs. You have to use just the frameworks that we provide you. The running of tests after build is not in the Express SKUs. The fakes framework is not in the Express SKUs. Code coverage is not in the Express SKUs. But you can now do unit testing, which is good. So what's missing? We made a bunch of changes, and some things are going to be perhaps frustrating if you are dependent on them and care about them tremendously. So let me give you a little bit of an explanation for why some of these things are changed or moved. The test lists feature that we've had since VSTS first shipped was a good idea. It really was. A list of the tests that I care about under certain circumstances. Perhaps these are the tests that I want my QA team to run, or the tests that I want to run on my build server every night for some sort of a performance check, whatever. The problem is the test list feature was also extremely broken, if you think about it from a developer perspective. Every time you added a new test, you had to go and edit the test list. And the test lists were also very, very tightly coupled to MS Test, which means they weren't capable of working with any of the third-party frameworks. So we removed it. If you have them from a 2010 project, they will continue to work. I said earlier, if it worked in 2010, it works in 12. But you can't create new ones. And our intent is to create a replacement for this capability that's much better, that really works. But we're going to have to wait for that for a bit. Test impact analysis, I mentioned it earlier on the build server, and it is still on the build server. And that's a good thing. But we discovered, in fact, that within the IDE, within Visual Studio, it failed to live up to its promises. It would actually give you the wrong answer sometimes, and it was very slow. And so what we did is we decided to remove it from the IDE. It still exists on the build server, where it has a lot of value. Removed it from the IDE, and we're going to replace it later. Replace the capability, replace the goal of being able to know which tests to run, in particular in the build after run, or the run after build continuous running experience. That's going to be very important. Try to optimize that experience down as much as we can. Private accessors were introduced a while back to allow you to unit test private methods. Basically, it was a code-generated snippet that did private reflection for you. In the MSDN docs for 2010, it was announced that it was deprecated and would be removed in a future version. It has been removed. If you have 2010 tests that use it, they will continue to work. You cannot create new ones. If you really need to do private unit test running, do the reflection yourself. It's only about 2 lines of code. And there's a part of me as a bit of a purist agilista that says, I want you to feel that pain because you shouldn't be testing privates anyway. But we can have that argument at another time. So let me return back to the premise where I started. We made a bunch of changes. Some of them are going to be a little bit painful. We apologize for the pain. We are trying to turn this experience into a developer-focused experience. For developers who care passionately about unit testing and writing their code, doing them together, and making sure that we are always achieving that, all of the benefits that we get from good, tightly entwined unit tests and code written together, running them all the time and running them fast. If you have any questions, I will be just outside the door over here. Also, I will be down at the booth, which is this Devo 1 TLC area. I have 3 other talks about different aspects of unit testing, including the deep dive for fakes on Friday. Thank you very much for your time this morning. Have a great rest of TechEd.